Good morning, and welcome to Rolling Out BIM or CIM in Infrastructure. I'll be discussing my personal experience with implementing a full CIM design here at HDR. I'll go over the processes we take and some of the successes and challenges I've encountered throughout the development, not just on specific projects, but also trying to meet our company goal of fully implementing CIM by 2017. Just a heads up, there's a lot to cover, so I'll try to get through it all as detailed as I can with the time given. I'll be posting my email address at the end, so if anyone has any questions or comments at the end that we don't have time for, please feel free to reach out to me. Okay, well, let me start out by saying thank you to all who are attending. For those of you that don't know me, my name is Stephen Walls. I've been in the AEC industry for a little over 14 years now, 12 of which have been with HDR in both their Northeast and Southeast regional offices. As you can tell by the list, I've worn many hats with HDR during my stint, between designing and managing not just projects and teams, but standards and procedures development as well. And I'm also in the final stages of completing our BIM initiatives for civil design practices. And if that's not enough, I've also teamed up with Advanced Solutions last year to start up a civil user professional network here in Charlotte. I also started up a LinkedIn civil information modeling group earlier this year, more as a way to communicate with others, really seeking information, insight, advice, whatever, or just who are in similar positions as myself looking to give their company an edge or an advantage. So like I said, there's a lot of information to be covered specifically with rolling out BIM or CIM within infrastructure. And here's a list of the topics that will be covered throughout the presentation. A lot of this may be familiar to some of you. Some of it you might be hearing for the first time. But that being said, topics that will be covered are obviously civil information modeling procedures, the execution plans, CIM workflows and CIM uses, training methods, and lessons learned. Ultimately, I'm hoping I could provide enough information to everyone so that you can implement a full CIM design at your workplace. So before we get really into it, I just want to go over a few acronyms that I'll definitely be referring to throughout my presentation. The first one, obviously, so we've all heard the term building information modeling, right? Or BIM being thrown around for quite some time now. In general, BIM is the process typically applied to and associated with intelligently and dynamically designing an actual building or structure, where architects, engineers, and designers can visualize and anticipate the true constructability of a project. I think you could all agree with me that on the civil engineering side, we've been designing and modeling everything outside buildings or structures in the 3D environment for just as long, if not longer, than the term BIM has been around. During this time, we've been able to build surfaces, corridor models, pipe networks. We've been able to produce dynamic profiles and cross-sections based on all that information. We've even been able to perform clash detections and earthwork quantities and generate reports and cost estimates. Now, although we've been producing some form of a 3D model within our design over the years, the final product has almost always been a hybrid of 2D and 3D design components. And for that reason, and that reason alone, at least from my personal dealings with project managers and clients, these designs have not typically been viewed as BIM by the vast majority. So there are multiple interpretations of the term BIM depending on who you ask. Some folks see it as a noun where everything related to it deals specifically with a building. Others see it as a verb where it's more related to the actual process of building intelligent information into your model. To clear it all up, on the civil side of things, HDR has decided to proceed using the acronym CIM, CIM, which I've already seen it being interpreted by others as either civil information modeling or civil integrated management, depending on who you ask. Either way, at least we know it's all specific to civil, right? So by incorporating similar processes used for BIM, we understand that the full CIM process doesn't end with generating a 3D model. Once a true 3D model or site representation has been developed, we can move on to additional dimensions that a model will provide, which allows us to extract and analyze the intelligent components plugged into our design. As clients and owners discover the value and adapt to this new technology wave, it's becoming more common for them to make it a requirement for AEC firms to include their 3D models along with hard copy plan sets at each design deliverable. I know I personally have seen it a lot, especially lately. Contractors are also getting involved in collaborating at much earlier phases of the project design. Since the introduction of BIM way back when, contractors have gradually shifted toward the same environment where they can take these design models and update it with additional construction intelligence, all while making in-field modifications and adjustments during construction phases. This process, currently known as Virtual Design and Construction, or VDC, allows for a more seamless collaboration, resulting in a much improved as-built final product, and obviously saving a ton of money on the back end. Now that we all understand what the acronyms are, let's move on to some basic CIM procedures. I can certainly vouch that implementing a true CIM design, especially your first one, is not accomplished easily. There will most definitely be some hiccups and growing pains along the way. You may even find yourself reach the breaking point of frustration, where you think that the only viable option is to go into survival mode and let old habits kick in. Trust me, we've all been there, and it's only made us better for it. Traditionally, design costs and efforts typically take the biggest hits during the intermediate and final design phases of a project, whereas a fully implemented CIM design will be front-loaded and taper off as the project design development progresses. Additionally, working in a 3D model-based environment tries an individual to really think about what they're designing and how it impacts the rest of the project. More time is spent upfront detailing a 3D model dynamically and intelligently in preparation of drawing generation and detailed analysis. As a result, any changes, revisions you encounter during the latter phases of a project will obviously take significantly less time to update and adjust. It's at this point that you'll begin to see the major benefits and cost savings behind generating a CIM design. During project initiation or startup, project managers and engineers need to sit back and look at the overall picture of the project and document what they want the final product to represent and best determine how to get there. 3D models obviously contain more information than your typical 2D record drawings, making the content more useful to us during the design process. On the flip side, it could also leave us very exposed to unforeseen errors and omissions. Model managers and project managers must work closely together to manage risk here, especially on non-traditional projects. BIM and CIM execution plans are becoming more commonplace, where design teams collaborate early on to put together a document outlining all of the BIM or CIM workflows and uses to be applied throughout the project lifecycle that will be most beneficial to reach that final product. Proper training is also required from the top down as well. An entire project team, not just designers, have to be educated and fully understand all the whys and hows to what it takes to put together a true CIM design. For the following 15 slides or so, I'm going to review an example CIM execution plan I put together earlier this year for a marina project in the city of Hopewell in Virginia. In typical report fashion, we obviously start off with the cover that kind of outlines the project name, the description, the project number, client number. This was for an environmental and drainage improvement project where we were tasked with redesigning an access road, a culvert, approximately 2,500 linear feet of stream restoration, along with some various wetland improvements and enhancements throughout the site. Next, we move on to the table of contents. So within our CIM execution plans, we have a number of different sections that define the project, the schedules, the BIM uses, BIM or CIM uses, project team roles, responsibilities, and their contact information, the LOD or level of development, as well as various procedures and workflows to be implemented throughout the entire project lifecycle. This document is meant to be a living document and is periodically updated as the design develops by the model manager or project manager. So running through it a little bit, we have all the project information outlined here, as well as the submittal schedules. We have this document linked up so it can access our project management tool, and will automatically populate these first few basic fields that deal specifically with the project name, number, description, and all. Continuing on, here's where the BIM or CIM uses are outlined. These are obviously project specific, and in this case we applied 3D modeling or model production, existing conditions modeling, roadway design and analysis, since we were ultimately going to be generating a corridor model, visualization, which was more of a client request. So once the project is complete, our plan is to integrate the entire model into InfoWorks 360, where we'll be able to provide better visualization to the client for public meetings and all. Another CIM use was 3D coordination or clash detection, and then obviously drawing generation or production, which is applied to all projects. There's a whole slew of different BIM or CIM uses that could have been applied to this project, but we didn't find it to be necessary, and we'll get into that a little bit later. Continuing on, for each BIM or CIM use to be applied to the project manager, lead engineer, or model manager is responsible for determining who will be working on the project for each use and rating that person's capabilities with the software. This helps project managers determine if any additional training is necessary before the project starts, or even if there's some sort of mentorship that could be accomplished. So looking at the 3D coordination or clash detection, it'll outline the use description, the value to the project, some of the tools that are going to be used, and then the skill sets. So ultimately you'll be rating each person's capabilities within the software for resources and competency. So in addition to the other ratings, we also have an experience rating, risk rating, and a value rating. This is all based on a 1 to 10 rating scale, and since I was going to be performing the clash detections, I obviously plugged in a 10 because I'm perfectly capable of providing this functionality, the CIM use. Moving forward, we also do the same for the 3D modeling or model production. Notice the H here, that just identifies that it's a horizontal project and not a vertical, such as a building or a structure. And it kind of just defines that we're focusing just on civil site work here for this CIM use. And again, we go through the whole ratings and the descriptions and the values. Moving on to the drawing generation or production, also designated as an H, as a horizontal project. These BIM use or CIM use descriptions and values and tools are automatically populated. So once they're defined, they're just automatically published with the document, and then you would manually fill out these, the rating system. Those obviously vary from project to project depending on who's working on it. Continuing on with the existing condition CIM use, I'll give you some time to read through this one. Here we have our roadway design and analysis. I'll give you some time to review this one. And moving on to the final CIM use of visualization. And again, I'll give you some time to read through all the descriptions and values. So once we have all that defined, we move on to the key team members of the project and the roles, responsibilities, and the contacts. So here at HDR, we have defined positions on all our projects to include a BIM project controller, a model manager, a model element author, and a model user. So essentially what the BIM project controller is they're typically relied on as the BIM expert who provides guidance and internal training as needed. With the model manager, they are basically the sole person responsible for leading and coordinating all BIM and CIM aspects of the project, collaboration, coordination with contractors, subs, all that stuff. Then we get into the model element authors, who would essentially be your discipline leads for modeling your project. And then the model user, who would be more of a junior staff position for EITs or entry-level designers. So once we've established our project team and designated specific individuals for each role, we'll list them all out. So here's the project team contacts list. Basically, this outlines what their contact information is, their role, what company they work for. So if you have subs, you'll outline that as well, where they're located, and all their contact information. Then we get into the LOD, or level of development, which really defines the anticipated accuracy of your design model. And in most cases, here at HDR, we try to meet the LOD 300 level. So elements are included as specific assemblies that are accurate in terms of quantity, size, shape, location, and orientation. Obviously, the higher LOD you go, the more accurate and better off you're going to be in the end. Then we get into the drawing creation strategy. And this kind of outlines not only the LOD, but how the LOD is going to be applied to your actual drawings. Just continuing on with the strategy for generating construction drawings, outlines how we're going to create our 2D details and 3D details. Then we move on to the collaboration procedures. So if we have folks in several offices working on this project, doing some work sharing, this kind of outlines how the collaboration efforts are going to be established, how we're going to continue the communication and coordination of our models. Next, we have meeting procedures and schedules. And here, as you can see by the chart, it's the meeting type. We outline at what project stage or phase each meeting is going to be held, the frequency, the participants, and the location. And then moving on to the interactive workflow, which kind of is more of a collaboration type workflow. Again, if you have folks working in multiple offices, how the collaboration is going to be accomplished. Moving on to our CIM QA/QC procedures, and it kind of gives a description of what our overall strategy is and the quality control checks. And then we get into the more defined visual checks, clash detections, standards, and model integrity checks. And that kind of outlines who the responsible parties are, gives a definition and the frequency for that as well. Here we have our clash detection matrix, and this kind of outlines the disciplines that need to be coordinated when you run a clash detection, and just the outline of your model coordination. When we get into the model accuracy and tolerances, so on this particular project, any pipe sizes that were 2-inch in diameter or larger were going to be modeled. And we get into the infrastructure needs, and basically this just outlines the software being used for each particular BIM use. Here's more of an outline of how we're going about our model setup, configuration, and which BIM and CAD standards are being used or applied to the project. And then finally we get into our drawing list, which is the last portion of the CIM XP. So I had a little extra time on my hands and decided to fill this one out. But in most cases, generally, we'll just leave a live link to our drawing index sheet here in place of the table, since this is constantly changing throughout the design process. I know this is meant to be a living document, but to constantly be filling this out, I mean, it just takes a lot of time, and it could really take up all your time to some extent, depending on how large the project is. I mean, some of these projects we've worked on are over 1,000 drawings, so you can imagine what kind of work would go into that, constant updates. And here's just a continuation or rounding out the drawing index. And so that's our typical BIM CIM execution plan. As you can tell, there's a lot of information to be filled out. The way we have it set up here at HDR is through an app available on our internal online portal. This app is linked such that, as I mentioned before, it could access our project management tool and will automatically populate the first few basic fields that deal specifically with the project name, number, and description and all. Also, as mentioned earlier, the project manager or model manager is typically responsible for filling these out. To be honest, it's a lot of paperwork to be filled out. It's taken me anywhere from 1 to 4 hours to finally obtain and track down all the information that I needed to fill it out accordingly. But I will say it's a great way of making sure that you have a concrete plan in place before you get started on a project. Now that we understand what goes into a full CIM execution plan, I'll go over some example CIM workflows. From start to finish, there are 5 major phases you'll see on a typical project. It all starts out with the logistics phase, where you ask yourself questions like, do we have enough resources, or will staff require training? Once determined, your company can logistically work on and is obviously awarded said project, we move on to the initialization phase. This phase is probably the most critical, as the flow of the remainder of the projects will be determined here. This is where you set up your CIM execution plan teams, define your CIM workflows and CIM use plan, and basically put together your strategy or game plan. Continuing on, after all this is clearly defined and documented within the initialization phase, you move on to the next phase, which is model management. This phase of the project is where the actual design comes into play. It will also include model coordination and collaboration, clash detections, reporting, and model QA/QC. Once the design is complete, we move on to our deliverables phase, where drawings are submitted for bid and construction. These deliverables can be submitted in a number of different formats. Hard copy plan sets are practically a given, but contractors are becoming more fluent with BIM and CIM processes as we move forward. I personally have seen a growing trend where contractors are requesting and relying more heavily on actual electronic models. This growing trend makes it clear that we need to verify the integrity and accuracy of our models through multiple QA/QC reviews and iterations throughout the design process, or model management phase of the project. The final phase of your typical project is life cycle. This phase includes record or as-built drawings, archiving, updating your libraries, catalogs, and templates, and lessons learned discussions. I'm sure you all can agree that the lessons learned discussions are one major process that's often overlooked. since the project is technically complete at that point and more than likely out of budget. I will say that this discussion should take place with the project team if possible, as it will definitely help your company improve on the workflows and processes implemented throughout the project development. Moving on to CIM uses. There are quite a number of different CIM uses that can be applied to any project. Each obviously has its own purpose or function and can be used in either one phase of a project or multiple phases. The four main phases of any given project where CIM uses can be applied are the planning phase, design phase, construction phase, and the operations phase. As you can see, the list of CIM uses within each phase can be quite extensive, and a number of them even have some crossover into the next project phase, which I've indicated using the red font. The majority of these are self-explanatory and pretty straightforward processes, but not all need to be applied to every project. As you all know, each project comes with its own set of requirements, and you certainly don't want to go overboard with defining all the uses that could be applied to each project. In my experience, you really want to stick to the CIM uses that are actually required to achieve the expected final product. Say you're designing a roadway for DOT. In most cases, the expected final product requirements are that you provide a hard copy plan set along with the 3D model of your design. With that in mind, the only CIM uses that are required to achieve that final product are design authoring, or 3D model production, drawing generation, or production, 3D coordination, otherwise known as clash detection, and design reviews such as QA/QCs. Sure, you'll probably do some sort of modeling of the existing conditions. This might not be necessary, but easier from an automation standpoint. I'm sure you'll also do some sort of a roadway design and analysis, as well as a traffic analysis. But if you plug this CIM use into your execution plan, then you're essentially locking yourself into meeting all the requirements of achieving that CIM use. If extensive analysis is required, or you and your company just simply feel better about it, then by all means, go ahead and add them. It will definitely give you and the client a much improved and thorough design. A real quick background before getting into some of the successes and challenges I've encountered. Here at HDR, we have a little over 10,000 employees and 180 plus offices throughout the world. We work on all sorts of projects from highways to streams, dams, levees, water, wastewater treatment facilities, railroads, oil and gas, mining, and the list goes on. That being said, we have multiple business classes and market sectors established, as you can tell by the list. In addition to the clear-cut market sectors and business classes, HDR is something they call cross-sector services. In that aspect, these additional services are essentially design teams strategically located throughout the world, where we assist each business class or market sector with their projects. I'm personally situated in our East Coast ASMEC Design Center. ASMEC is really just a shortened version of naming every discipline. So we've got the architectural, structural, mechanical, electrical, and civil. So that being said, we have professionals of each discipline within our group supporting each business class in some fashion. Being that I've been involved with and worked on all sorts of projects supporting the majority of our business classes, I've had the opportunity to learn what it takes to develop a true CIM design across the board. Last year, our president of the company put out a goal to each business class and market sector to be a full BIM and CIM implementation by 2017. Sounded great in theory, but how can you really accomplish that? In a lot of cases, project teams throughout the company had no clue what BIM or CIM really meant, let alone implement it. I'll tell you that there were a lot of naysayers at the beginning. Still are some. Luckily, I was situated within ASMEC, where we've been using BIM tools for several years now. ASMEC has always been viewed as a high-level design center and have had access to all the latest technology. We've even had a jump start on developing some very generic documentation on BIM and CIM uses and all. So we've essentially done all the legwork for each business class. Being that I'm leading the CIM implementation efforts here at HDR, I'm on several conference calls a week from folks all over the world trying to facilitate and coordinate efforts between the market sectors and business groups. Each group has their own opinion on workflows, what tools to be used, and life, really. My main job is really to clue everyone in as to what's out there, what's been developed thus far, what other groups are working on, their initiatives, goals, etc. This way we know efforts aren't being duplicated and variations are limited as much as possible. All that being said, with all the conference calls and meetings we've had, we all came to the conclusion that we need a baseline to start with at a minimum. Can't get too ahead of ourselves, really. If we can come up with a baseline BIM or CIM standard outline of what will be implemented on each project moving forward, then the rest will fall into place, and it can be developed later on. But we needed to start somewhere. After much deliberation, we all came to the realization that there really are only 4 common CIM uses that would and should be applied to all projects, regardless of which market sector or business class it's for. And these are the 4 fundamental CIM uses, which are design authoring, drawing generation, 3D coordination, and design review. So design authoring is the process in which software is used to develop a 3D plus model based on information required for accurate translation of the design. One thing to note is that quality control is involved in every single phase of the design and within every CIM use. The QC process related to design authoring typically focuses on the accuracy and completeness of the CIM elements at a granular level during interdisciplinary design, whereas the QC process during 3D coordination and design review provide a broader look at interdisciplinary design and focus more specifically on errors and completeness. In practice, these lines are not distinct, and quality plays a pervasive role in CIM like it does in all aspects of the project lifecycle. The most important factors to consider when modeling existing conditions is determining the level of detail needed in the model. This is typically addressed while developing scope and fee and should be discussed between the project manager and the lead modeler. Please note that designing with an imprecise existing model will create constructability issues and will create risk to your company. On the flip side, excessive detail obviously increases survey costs and processing time. Identify level of detail and boundary to limit overwork. So determining the level of detail depends on the project type and client requirements. This can obviously vary greatly from project to project. I'll give you a few example factors that should be considered when determining the level of detail to incorporate into your existing models. So as an example, say you have a linear roadway design. You ask yourself, will there be a new pavement adjoining existing? You'll obviously have to review the contract, your client specifications, and design guidelines to determine accuracy requirements. The design output cannot have a higher level of precision or accuracy than the underlying survey. Say you have a project that involves civil site grading. Different areas of a project may require different levels of accuracy. Landscaping and mass grading don't typically require the same level of accuracy and detail needed for pavement design. You'll also need to consider drainage and surface tie-in points. Say you have a utility relocation project. You'll need to find out how many and what types of utilities are in the project area. If there are high-risk utilities near proposed structures, borings might be a better source of information than ground-penetrating radar. Also, if clash detection analysis is to be performed on the design, then all utility information needs to cover the area of the proposed clash detection area. Next, we have drawing generation, which essentially means the process of taking CIM components and creating drawings and or drawing sets, including schematic, design development, and construction documents. The broader objective here is to define model elements only once and to use that information with no loss of accuracy or integrity to generate your drawings. This obviously improves the quality of the drawings and reduces effort and errors in the design process. For most projects, plans are the primary deliverables, so drawing generation really isn't a new concept. The difference between drawing generation before and after CIM implementation is that designers can now show information in any 2D view rapidly with little to no loss of precision or accuracy. Plans, profiles, sections, and detail sheets can all be generated from your model. Next, we have 3D coordination, which is more often referred to as clash detection. 3D coordination is the process in which 3D design software is used to identify spatial interferences of objects, such as utilities, drainage pipes, pilings, etc., in one or more 3D models. The goal of clash detection is to eliminate major system conflicts prior to construction. 3D coordination is a continual cycle throughout the design process and should begin prior to the first project milestone, as outlined in our CIM execution plan. On the flip side, the time to start 3D coordination and frequency has budgetary implications. 3D coordination on conceptual drawings will obviously produce false positives because elements have approximate dimensions and solutions to design challenges in constrained areas have not been investigated. Furthermore, excessive clash detections waste time and project budget. One thing I'd like to stress here is that you should not rely solely on 3D coordination software to verify that there are no conflicts within your project. Yes, clash tools are helpful in identifying physical conflicts, but everything has to be set up perfectly for 3D coordination to work as the sole basis for verifying your design. Ultimately, the responsibility of avoiding conflict falls on the design team, and a no conflict report from a program is not a basis to defend a problem within the design. 3D coordination works best when the elements you are verifying are on appropriate layers or levels in the drawing itself. Our standard practice here at HDR is to keep a record of the base files being compared, where we'll export a read-only 3D coordination model with a date and store in the same folder as our report. Once we have a complete report, we'll identify individuals responsible for resolving each conflict, whether it be through redesign or subsequent engagement with other disciplines or owner. Coordination is not complete until responsible leads or designers have acknowledged the conflict and acknowledged ownership of the conflict resolution process. So the final core CIM use I'm going to go over is design review. And by design review, we mean nothing more than just taking our 3D engineering drawings and sharing the content with other people. Design review isn't really formalized, but it does typically take on two primary purposes. The first is to verify quality, with a focus on problems that are otherwise difficult to identify. The second purpose is to communicate design information to other designers or outside audiences as quickly and accurately as possible. For all projects, we're expected to deliver services that meet a standard of care, which requires plans that are free from errors and omissions. Errors are easier, at least relatively speaking, to identify than omissions because they appear in our drawings or computation sheets. Omissions are harder to identify because they don't appear in the plans. Omissions in geometric design, for example, a retaining wall required by roadway geometry that is missing from the base design, are something that CIM is uniquely qualified to help address by making it easier for a larger audience to gain a holistic view of the project. That same perspective helps us identify constructability concerns as well. Communicating design information presents two unique challenges. First, audiences do not universally have the software or technical skills necessary to navigate the 3D files. This is considered to be an accessibility challenge that design review can help overcome through in-person meetings, teleconferencing, and sharing content in videos or images. Secondly, each group of designers or stakeholders is interested in different elements of the design, which becomes a content challenge. Visitors at a public information meeting care about things like control of access or retaining wall art. Designers care about geometric conformity and standards compliance. The challenge in tailoring content is handled through execution. This specific CIM use is meant to help with that as well. Design review often occurs at staff-level design meetings. A common focus is to verify constructability and completeness of the design as described in the previous sections. Comparing two alternatives is one of the most valuable uses for CIM because it allows design staff to understand the consequences of choices at a high level of detail with the minimum amount of time. It's preferred to use a consistent vantage point or points of view to make comparing the alternatives as easy as possible. So the final piece of the puzzle is training. All these procedures put in place sound great and makes everything seem like we're organized and know what we're doing, right? Unfortunately, we can't just throw all this information out there and expect everyone to just follow it. There obviously needs to be some process put forth for everyone to receive proper training and follow-up. Some of the things we're doing here at HDR are putting together 5-minute training videos and demonstrations on all the CIM procedures I've mentioned. We are also in the process of setting up several summits where we are inviting power users to one location where we can sit down with them and provide a more thorough review of the documentation. The thought is that we train these power users so that they could sit down with folks in their respective offices and train them. Since we have several BIM and CIM teams strategically located throughout the company, covering each business class and market sector, specific questions, comments, suggestions, troubleshooting, or any other kind of follow-up that will be directed to each of these teams. We're also providing a more high-level 3D model training where we review more of the advanced functions and tools within Civil 3D and some of the advanced workflows we've established. In this aspect, we find that it's really important to make sure everyone is on the same page and conforming to the same workflows and procedures to make sure things are consistent across the company. I've also put together an internal Civil 3D user network website using SharePoint, which is looked at as a main communication portal for all things related to Civil 3D. On this SharePoint site, users are free to provide tips and tricks, CAD standard updates to blocks or detail libraries, styles, catalogs, etc. There's also a couple different discussion boards set up for troubleshooting, standards and workflows, general discussions, and we even have work sharing opportunities set up with folks in other offices. Had enough yet? I realize it's a lot of information to take in, so I did want to say thanks again for bearing with me. I hope I didn't put anyone to sleep. I know we're working on quite a lot of different things here at HDR, and personally, I just find it to be an exciting time for all of us. Technology is advancing and becoming developed at a faster rate than we've experienced in the past. I mean, just take a look at InfoWorks 360. That program alone is leaps and bounds ahead of where it was a few years ago. We're definitely moving into that model-centric design environment, and we just want to be prepared for it. Again, just want to say thanks to everyone for attending, and please feel free to reach out to me if you have any questions, comments, or anything you'd like to discuss. Here's my contact information, and I'll open it up now to questions we have.